to actually write that column directly in the database over the blob streaming engine, which is MyBS for short. So the next important step is to actually separate the blob data out into its own repository. This is important for a number of reasons, but as a blob repository is basically a collection of blobs where I no longer then have blob directly in the data, but I have a reference to the blobs in the no longer have blob in the table, but I have a reference to the blob in the table. And there's a number of good reasons for doing that, and one of the problems was already mentioned, that if I have several columns in the table and one of them's got a blob in it, in MySQL today, if you want to sort that or select it, it takes a heck of a long time if you're including the blob column in your select. And also allows us to handle the blob data differently to the standard data, which becomes very important when you're talking about terabytes of blob data. And a lot of the databases that we do, which is the multimedia area and print media, are basically small database with a huge amount of blobs. So the database itself, without the blob data, is very easy to handle, but the blob data is what's causing the problems. So there, basically, the idea behind putting the repository in MyBS, so Falcon has its own blob repository, so actually that could, so MyBS could access the Falcon repository directly, but the other database engines actually don't have repositories, and so it makes sense to put a repository in the streaming engine itself, and that will enable other engines like even InnoDB to integrate the blob data in the repository into an InnoDB table, for example. Okay, I'm going to skip that. Yeah, like I said, there are two types of references. I just demonstrated the first type of reference, which is a blob field reference. The other type of reference is a repository reference. And I think the best thing for me to do is to just demonstrate. Wait, I'll just go through this slide here. The way it happens is when you, if you're storing a blob in the repository, the basic way to do it goes like this. The first thing is you upload the blob to the repository. That's step one with HTTP put. HTTP put, you're uploading a blob to the repository. And you get back from the repository basically a partial URL. That's this strange test/strange number, which identifies the blob in the repository. And then in the third step, you place that reference into the row that you're about to insert, and then through a normal SQL insert, you insert that into the database. And then step number 5 is a hidden step which occurs automatically, where the engine which is storing the reference in the row calls the streaming engine to reference that data. So it says, I now have a reference to this blob in your repository. And the repository then remembers which columns are actually referencing it, so that it knows, okay, I don't throw it out, obviously, or knows when to throw the blobs out of the repository when they're no longer referenced. So I'll just...
And presumably, if you never make that call, is the
yeah.
timed out after that?
Yeah, exactly. So there's a timer set when the blob is uploaded to the repository, and it's counted down. The timer is settable, and it's counted down currently after 2 minutes. That blob is removed from the repository when it's not, if it's not referenced before that time. That's possible.
It keeps the reference.
It keeps, yes. Basically, it tracks all of the references from the database to the repository. So I'm going to use curl to upload a blob to the repository. So I came back with this reference here. Now we can, if I'm quick enough, I can actually get that from the repository already.
They're quick enough in beating the time to live.
Exactly. Oh wait, I'm going to do with curl because of the content, right? So I'll just take what I can. Okay, so I've uploaded, obviously I can download it as long as it's, as you mentioned, as long as the time doesn't time out. And so to make sure that that stays.
Is the timeout a security mechanism?
Yeah, if you upload a blob and the client crashes, so it's not really a security, you asked that question. It's not really a security thing, it's more like you can't trust the clients, to do the insert, which I'm going to do now. So now I insert that reference into the column. Okay, so good.
Doesn't that insert the actual value?
No, that inserts the reference. I mean, I've just inserted that text, but it knows that's the engine, which is streaming enabled, knows that that's a reference to a blob.
How does it know that that's a reference versus the actual blob data itself?
Because it's got a funny format. Because that's the way it's doing it at the moment.
Right.
So it knows, okay, this thing's coming in and it looks at it and says, oh, that looks like a blob reference. And of course, the streaming engine says retain. And the streaming engine either says, oh, I've done it, this really is a blob reference, or it says, go away, it's not a reference.
So maybe the data type of the reference column.
I could, yeah.
Only switch like a big column parse any sort of quote, J or something. Also use a specific column.
Yeah, that's possible, but then I'd have to add a data type to MySQL, for example.
Yeah.
Okay, so not being able to do that at this stage, it's easier to do it this way. I could also make that blob reference a little bit more complicated with some sort of prefix or something to make it more obvious. More obvious, more unique.
Why don't I just add a column with data type, like enum, binary or reference. As a third column. Then you know for sure. Add a third column.
You mean add a third column, and the column is really the reference, or what?
So the column on your notes tab table, you have a third column, enum, with two options, either reference or blob.
Oh,
and then,
okay.
Then you have a definitive answer every time.
Actually, there's other tricks I think that we can do without having to add an extra column. The thing is, probably when you're doing this, you're not going to mix and match anyway. You're either storing blobs directly or you're storing references. So it's unlikely that you have a situation where you mix and match both. And one idea is to take that column and say, select and have a function, built-in function, which says select blob reference from n-text. Okay, and then that function would know, okay, he just wants the references back, or I say select blob data, and then it says, okay, I know he wants the blob data now, I'll get it from this streaming engine and pass that back.
I would imagine though, if you have large blob data, which is the point of this, it would be a big performance hit if you're checking the string format on each row to check if it's a reference or not.
No, I don't think that's a big issue actually, because that's a small string. I mean, I just checked the last.
I just have to check the format of what's not the reference, which is blobs.
You mean if I've got like a 2 gig blob and now I want to check the format?
Exactly.
Actually, it's pretty basic. The thing just jumps to the engine of the blob. If you've got a 2 gig blob in MySQL and you're inserting it, then it's all in RAM. So I just jump to the end and I move back and see if it's got, you know, three dashes and a slash, and that the things are digits and there's hex digits and so on. Make a few checks, and then when I've done that, then I call the blob streaming engine with maximum of 200 of those bytes, and the blob streaming engine will then tell me if it's valid or not. It's just that I do that check before calling the blob streaming engine, because calling the blob streaming engine is a bit more expensive. So, but the streaming engine will know if it's got if that's a valid reference or not. This part of the reference is a random number.
The first question is it a reference, and then the engine will tell you if it's a valid reference.
Exactly.
And presumably, if it's not, you just return it as a string because
If it's not, would just store it and forget about it. And later, when I delete, the engine will tell me again it's not a valid reference and won't dereference anything. Okay, so I'm going to skip ahead a bit now because what I'm going to show you is that there's a view to the repository. So the repository's got two system tables. Skip ahead to that. Yeah. Okay, two system tables. One's called MyBS repository, which contains one row for every blob in the repository, and the other is MyBS references, where you have one row for each reference to that blob. And we can take a look at the repository now. Okay, it's pretty wide.
2/G.
What is that?
backslash capital G instead of semicolon.
Backslash G?
Yeah.
Backslash capital G. So
That's vertical mode.
again, but instead of semicolon.
The query again, but
Just hit up arrow.
Instead of semicolon at the end, use backslash capital G.
oh, okay. Right. Okay, only one row, it's easy to see. So this is one row, which is the blob, and you'll see actually the actual blob data is also outputted here. Basically, this is all rows now, but this is the primary key. It's a repository ID and a repository and offset, because a repository is a series of files, and this identifies the exact spot of the blob in the repository. And also interesting are the references. So this is the primary key of the references table. It's telling me that this blob is referenced by the notes table from the column ntext, and the primary key condition for that is ID equals 3. So it's actually telling me exactly where that blob is referenced from the database. And the blob URL is also here. And the deletion time is set to 0. That becomes non-zero when I delete the blob. And the same applies to when I upload the blob. When the blob is deleted, the timer is set, and it's only actually removed from the repository after that time expires.
Isn't the URL the same for all blobs?
Beg your pardon?
The URL, is it the same for all blobs? I mean,
No. Yeah,
I'm wondering why it's in this table.
exactly, yeah. Exactly. One would think that it would be in the repository table. The reason why it's in this table is because the URL changes when that blob is referenced from a different table. The first number here is the table ID. And the second number here is a handle. And the reason for that is because blobs can be moved around in the repository. When a whole lot of blobs are deleted, there's a huge hole in the repository file, and that is compacted. And by moving the valid blobs into a new repository file and removing the repository file, at that point, the blob handle is updated. And that has to be done, and these handles have to be stored on a per table basis because basically it's an optimization. I have to know if the table is dropped, I have to delete all of the references to that block. It works, yeah, it is atomic, so the actual the operations between the engine and the engine and the blob streaming engine are atomic. Although the blob streaming engine itself is not transactional, it works transactionally. Basically, by controlling this timeout, which for example, if let me just demonstrate the timeout quickly. So I've got these three, and I'll delete the one with the blob. Yep. Okay, obviously it's gone here. This is, but the reference is still in the reference, and the blob is still in the repository. But the reference now has a deletion time and a remove in, and that's time in seconds, which is now counting down. So when that time is up, the blob will be removed. The reference will be removed, and because it's the last reference, the blob itself will be removed. And the reason for doing this is because people might have done a select already and are now going through that select and actually accessing the blob data. And then a delete comes along, and you want to give the selects time to actually access that data. So according to, 2 minutes here for this timeout is pretty low. You'd normally set that to about whatever, 10 minutes, depending on how much data is to be retrieved, to make sure that the select is not done and then the blob data is not available with you. That's why delete is delayed. Okay, so that's the blob timeout. One of the questions came up when we discussed this earlier is how does MySQL dump work with the blobs not read in the table? If I do a select then I get that, so where's the data? But basically, the problem is solved with the system tables because MySQL will dump the system tables as well. So it will actually part of the repository data and the references to that blob will be part of the MySQL dump. And so obviously the system tables have to be writable, which they aren't yet. But in order to solve this problem, I have to be able to actually insert into the repository tables. This only works though if your blobs are all under 4 gigabytes, which is the maximum size of a blob in MySQL. This actually works, MyBS, the blob streaming engine actually works with blobs which are bigger than 4 gigabytes. As long as you don't retrieve them over the normal select, you basically retrieve them through the streaming interface. That size is not sufficient. Okay, I'm going to just. Okay, this is the last time I'm going to actually show how can replication work under these situations, under this system, because it's actually quite interesting. So you'll see the first phase of this is quite interesting. Is what we know already. The put in step 1, the blob goes in the repository. In the step 2, the reference is returned. That's placed into the row, which is inserted in step 4. Now, replication only knows about that insert. So the replication replicates the insert with the reference. And when it gets to the slave server, the slave engine calls the blob repository, local blob repository saying retain, and that repository realizes it doesn't have the blob. That's the question mark there, step 7. But the reference tells it where to find the blob. So it takes that reference and does a get from the original engine and pulls the blob into its own repository, and basically the replication is and you need an optimization. There's basically the optimization would be to push the blobs from the master to the slave, and then the system can actually push multiple blobs in parallel. And this is the basic idea about how a distributed repository will work. It basically involves not all repositories having the blob data, but knowing where to find it. So the caller will get a redirect. All right. And I think
How does this work with master replication? Is that handle that scenario perfectly?
You mean master in the sense of write into both masters?
yeah.
Just
Master slave to another
It
master.
would actually, you know, if you've got the master setup actually working, just for the normal non-blob data, the blob data wouldn't be a problem. You know, the two repositories would just pull the data
So there's
from one to the other.
nothing idiosyncratic about this architecture that would never.
Yes, exactly. So, I'm not going to go through the details because we want to get on to more refreshing things. I just want to list the website. For more details, blobstreaming.org is, I also post this presentation. But there's some documentation. You can download the engines, try them out, send me your bug reports, so on. And a couple of other resources, PBXT's, my blog, where I also always announce new releases and so on. Let's also, if you follow Planet MySQL, then
Is it Blogspot or Blogspot?
blobs, blogspot.
Yeah, pbxt.blogspot.
Oh, thanks. I wrote blog like 5 times.
So,
Here's a redirect, go for it.
I believe I've enabled any logged in user for the MyFlow campsite can upload files now. So feel free to.
So our fourth denial of service,
Say what?
our fourth denial of service attack will be to upload files to it.
But anyone who
That was the
did
first,
a presentation today that wants to share all that information, you know, feel free to do that.
Or at least post an URL to it as a...
Yeah, a tiny URL or something like that.
Yeah.
Okay.
What does PBX stand for? PBXT.
PBXT is Prime-based XT. It's a transactional storage engine. So actually, I've got it running with PBXT because I've got access to the source code and can integrate things into it. But there's no reason why the blob streaming engine shouldn't work with InnoDB. As I said, there's this, or MyZan, there's this server-side blob streaming API that's got to be supported. A couple of calls that have got to be placed in a few spots. And I'll probably, if I have time at some stage, then I'll also work on patches. But Chad, you've got to get them integrated for me.
So that engine is what kicks off the process on 88 in this computer.
No, the engine that does that is the streaming engine, which is called MyBS. That's the blob streaming engine. That's the one that supports that listens on the 8080 port.
What file format? Does it store each blob as a separate file? Or
No, the repository is a series of, is a group of files on each blob. The blobs are basically stored one after the other in the repository file, and you have a limit to the size of the repository file which is configured, and then it creates a new one. And then, as I said, if a blob is deleted, it reclaims that space by, basically it watches the garbage threshold, and when the threshold of garbage it exceeds a certain percentage of the file size, it copies over the valid blobs into a new repository file and deletes the old.
The sparse file on this, when it deletes.
Beg your pardon?
Sparse file on this, at least in the middle of the file.
Yeah, it just marks a blob, it deletes in the middle of the file, just marks a blob. The blobs themselves are though contiguous within the repository.
Yeah, no vacuuming, it just migrates pages or blobs
Yeah.
to the next
It's
repository file.
a kind of compaction. Yeah.
What do you see as the main advantage of this over using a distributed file system or other file stores? Because it's still not atomic in terms of the upload into the table, right?
Well, it is actually atomic because of the timeout. So once it's referenced, the blob the blob is uploaded.
Oh, so it won't go away.
If it's not referenced within a certain time, it's deleted.
Right. Okay.
But it's no more atomic than you could make a distributed file system-based approach. You could do all of that.
You could do
on
that.
top of a distributed file
You
system
could do
as well.
that. All that. So from that point of view, it's maybe.
So I think part of the answer was, as far as the advantage would be the much reduced memory consumption in actually reading back large blobs. Because in the current state of affairs, if you read back 100 meg blob, it needs to be allocated several times over in order to send it back to the client.
Yeah.
Maybe it's
Say that again, but I don't know.
So if you're storing large blobs, really MySQL is not very useful for storing very large blobs.
Right, that's my impression. Most people don't use
That
that.
the size of the blob itself has to be allocated several times over to send it back to a client.
Yeah, but he's asking about the file system, not putting it in the database.
Right, there are a lot of people using it.
Correct. But that was the question was, what are the advantages?
Okay, but if you've got there's another advantage of over the file system. The fact that the repository stores multiple blobs in one file is already quite a major advantage. So if you're dealing with like 20 million little blobs, you're probably only going to end up with like 10 or 20 repository files. But you're storing that in a file system, then you're dealing with 20 million little files. And there's no normal file system that's going to deal with that amount of files very elegantly. Yeah.
But if they're truly little files, then you could store them in the current blobs fairly easily.
Okay, but if you don't know how big they are, so if their average is like 20K, but you've got some which are massive and some which are
Sure. Then it still sucks.
then it still sucks. Because you've got to cater for the biggest possible with your configuration, MySQL.
Can you set it up so that it stores some, like, the size threshold? So that the smaller stuff is actually stored in the table and then the larger stuff?
Right now, there's nothing stopping you from doing that. As you can see, I can store the normal blob data or I can store reference.
Okay.
So you could have that logic on the client side. Obviously, it would be more elegant to have that on the server side. And both are accessible over the streaming interface, but you would have to use a blob reference on the one hand, in the one case, and a field reference in the other case.
Right. So you have to know what's going on.
Yeah. Okay, what I didn't show you there as well is that the blob repository also stores the content type on the upload, so that on the download it returns that content type. That's also something that... So you can actually do a select and place the URL directly in the browser without actually having to touch the data.
Is that based on what you specify when you upload it?
Yes, that's based on the content type when you upload it.
But you could do, usually most people with matrix or figure it out.
I don't know how that works.
So are there any sites using this in a high, traffic environment?
I think if I put in more than 1 or 2 blobs, it'll crash. It's just, it's alpha. No, but the basic functionality is there, and the next steps will be to get it running with the real amount of data.
Are there target industries you think will make use of this in a hurry once it is more told?
I don't know if there's one specific target industry. One group of people interested is a website which stores, which will be storing the production, what they call, yeah, I don't know what it's called, the technical term, but it's basically the movies from a production of a film for a day, wanting to make that accessible to all the people.
The dailies, yeah.
Dailies.
Could be useful for medical
Or even text data, yes.
I would say in the legal community, when we have thousands and thousands of depositions, or we want to search for when a person says a particular word, you would type that in and up would come up that particular part of the of the deposition.
Yeah, definitely anything multimedia, but also that would probably be more PDFs and so on.
No, it would be video. We do a lot of video.
Oh.
So you play that back in court. Somebody's saying something. I never said that. You type it in.
I think the key issue is not you know, who's going to use it. I think a lot of applications store this kind of data. The key issue is to make it good enough so that that people want to use it, rather than make their own solution which involves the file system and so on. So that's our goal here, to make it good enough to solve the problems of distributing and handling really huge amounts of blob data, and to solve it well, so that people, so it actually helps.
Yeah, so maybe this is a more involved question, but how do you handle updates and changes to, once they're stored in the repository, if I want to swap it out?
Exactly the same way as the insert. You'd upload the blob that you want to change, and then just do the you'd upload the blob that you want to update, and then do the update by setting that column to the reference. So that's
you just swap the reference onto that.
Yeah, the engine would get on the server side. You'd have a retain, and you'd have and when that record is deleted, it has the old reference. You'd have a release being called to the blob streaming engine. So it would release the old reference and retain
so existing references until you update them would still point to the old version, basically.
Yeah, I didn't demonstrate that, but actually until it's actually committed, both references exist.
Okay.
Yeah. Okay.